Hello, I'm Gustavo Quintero, and this is my modeling case study for control theory. So here's the system, the model. So this is our mass dampener system. There's two frictions, one dampener, two springs, two masses, and then a force applied to our system. So here's our block one equations. So first we start off with our system equation. That's equal to 0 because it's attached to the wall. And then we go into, from the time domain to the frequency domain for the Laplace. Then we distribute and separate our variables from x2 and x1. Then we solve for x2. And then we plug in our constants, which would be the spring coefficients and the friction and dampener. And then we simplify our terms down there. Here are our block 2 equations. This is the model block 2. We first start off with our system equations that are equal to the force, and then we'll Laplace from the time to frequency domain, and we distribute out. Then we factor out our x2 and x1 variables, and we plug in our constants, of course, and then we simplify, still equal to our force, block 2. And then we solve for the transfer function. So we plug in our x2 into the x2 of our block 2 equation. So that's plugging in our x2, and then we multiply out that denominator right there from our x2 solution, and then we solve for our transfer function. We divide over our f of s and our x1 to get the output over, or the input over the output, which gives us this right here, and then of course we can simplify down to our final transfer function. So this is the open loop system model. Here's the transfer function right there. And then this is just our block model system of the step function in our scope. Here's the full system model. This is the full transfer function system. This is our x1 and x2, or our mass 1 and mass 2. And those are our respective blocks, and these are essentially our variables right here for the full system model with feedback. So these ended up being our step response results. So figure 7 is our MATLAB plot. That's just putting the equation to apply MATLAB. This is our open loop Simulink plot with the step function. And we can see that this goes right over the amplitude of 0.25, all of these right here. And then this is the plot with the feedback, that final system that we looked over from Simulink. We can see all three responses are exactly the same.